Hi, in this video we will introduce the complex numbers and the operations of complex numbers. The starting point is that, this is easy to see. There is no real number x such that x squared is -1. No matter x is a positive number, real number, or negative number, when you multiply it to itself, you get a positive number. For 0, it is obvious you get 0. So we won't have any real number whose square will be a negative number. In particular, we won't have any real number whose square is a -1. Well, we like to introduce something which has this property. We introduce the symbol I, which has this property: I squared is equal to -1. Or in other words, I is root a -1. Well, as you see, there are no real number which has this property, so this symbol is not going to be a real number, so it will be an imaginary number. So this is where the complex numbers start. So a complex number is a number which has two parts, is a number of the form a plus bi, where a and b are real numbers, and I is the number we just introduced. The symbol I squared is -1. Well, these numbers, as you see there, they have two parts. The part without I, we call it the real part. And the coefficient of the I, the symbol I, we call the imaginary part. Imaginary part. So they will have two parts: real part and imaginary part. First thing to see is that the real numbers are special case of complex numbers. Real numbers are complex numbers. In other words, real numbers is a subset of complex numbers. Why? So if I have a, any real number, plus 0 times I, this will have no imaginary part, and this is real number. So every number, real number, is basically an imaginary number, a complex number with imaginary part equal to 0. Well, there is a geometric way of showing complex numbers. In the real numbers, remember that we had this real line, yes. And while it has 0, then 1, and then you choose everything based on that. And we denoted the real numbers by R. Now we go to the complex numbers. The complex numbers will have one real axis, one imaginary axis. These guys are 1, 2, and so on. This is real part. This vertical one is going to be the imaginary part. And this is now, if you have such a thing, you call it complex plane. This is not anymore a line, it is a plane. And the way we denote this is see an extra line there. So complex numbers. And while each number is again a point here, so if you have a plus bi, so you pick a from the horizontal axis, b from the vertical axis, and then you have a plus bi. So every point, in other words, if you forget about the I, every point A, B basically shows you the complex number A plus BI. Very nice. Well, introduction of these guys, for example, you can have numbers like 1 plus I, or 2 minus 3I, or just 4i, and so on. Yes, so these are the complex numbers. But the important thing about the complex numbers is that we can do all the operations that we had for real numbers here for the complex numbers. So let me start this part, operations of complex numbers. So to start with, everything you can add any two complex numbers. So addition of complex numbers. So if I have a plus a I b, then I want to add it to c plus I d, di. This will give us a plus c, add the real parts, that's the real part of the sum, and add the imaginary parts, then multiply it by I. For the subtraction, we have a plus ib minus c plus id. Subtract the real parts and subtract the imaginary parts. How about multiplication? Well, multiplication doesn't have anything new, but you just multiply by distributing multiplication over addition, multiplication. So if I have a plus ib times c plus id, what we do is that expand. Let me just expand this guy over that and then that one. So we will get a times c plus ad times I plus bc times I plus ib times id. What you need to note here is that I have here I squared bd. I squared, by our convention, I squared is -1. So this will be -1. So what we have, this part is real part, this part is real part. So put those together. Plus, these guys are having some I. So it will be AD plus BC times I. Again, just expand it. So let me write it here as you can see, AC minus BD. Why minus? Because when you multiply I to I, you get I squared, and that will give you negative. And here would be I, or BC plus AD times I. Just expansion, and that would do the job. So the next thing is division. Yes, how you can divide two things. For that, let me just introduce few new things here. One is called a conjugate of a complex number. So if I have z, the complex number a plus ib, or bi, doesn't matter here. The conjugate, the complex conjugate, sometimes people say, we denote it by z bar. It is a minus bi. So just you get a minus sign there. And something nice about the conjugate is that when you multiply z to z bar, you get a plus bi, a minus bi. And if you multiply such a thing, you will get a squared minus bi squared. But bi squared has b squared and I squared. I squared itself is negative, and bi. So this will give us a squared plus b squared. So when you multiply a number, complex number, to its conjugate, it will give you sum of the squares of this real and imaginary part of that. And you remember that if we have a vector a and b, the length of the vector will be square root of that. And here we have such a notion, it's called absolute value of the complex number. So z, this is how we denote it. The a plus ib, the absolute value of complex number a plus ib is root a squared plus b squared. Yeah? And you just find that. Now, why are these guys important? Because now I can use the conjugate and tell you how to do the division of two complex numbers. So fraction of 2 to a plus ib, I want to divide it by c plus id. What we do is that you multiply both numerator and denominator by the conjugate of the denominator. When you have conjugate of the denominator, you see that in the denominator you have the number multiplied its conjugate, so you will get real part squared plus imaginary part squared. And in the numerator we will have a plus ib times c minus id. We know how to deal with the complex product. You do multiply the numerator and you will have basically ac plus bd over c squared plus d squared. C squared plus d squared is going to be a real number plus I times bc minus a d over c squared plus d squared. In particular, the inverse, this is division. In particular, the inverse of a complex number, so inverse. If a complex number is non-zero, then we have 1 over a plus ib. What you do, you multiply a plus ib, then you multiply this by a minus ib divide. You will get a minus ib, a squared plus b squared, and this will be a over a squared plus b squared minus I b over a squared plus b squared. So you can find inverse of a number, which is basically a special case of the division that you see. If you know inverse, you know the division. If you know the division, you know more things, which is inverse. So you have to be able to write all these operations to start with, express them as real part plus I imaginary part. Let's do some examples for this. Okay, express the given expressions in the form of a plus ib. Here, first one is the addition. So you have 2 minus I plus, note that this is 0 minus I. Or you just consider I as a symbol and just add the expression. So this will be 2 plus 0 plus negative 1 minus 1 times I. So it will be 2 minus 2I. Let's multiply this guy. So we will do 3 times 1 plus, I'm doing all the work here, you need to see this, plus 2i times 1 plus 2i times negative I. And this will be, you see, this is 3. Here there's also, there's a real part. This is I times minus I, or I times I is negative 1. There's a negative sign. So that will give us just 1 times 2. This is 2. This is real part, plus 2 minus 3 times I. So 5 minus I is the complex number. So this A is 5, B is negative 1. 1 over I, you remember the conjugate. I itself is 0 plus I. The conjugate of I is going to be 0 minus I. So you multiply minus I to numerator, minus I in the denominator. You get minus I over I times negative I, which is I squared times negative 1. It is 1. It is interesting that the inverse of I is negative I, and that's only for I. For other things like the example you see here, we need to do the trick that I just mentioned. 4 minus 3i, conjugate of the denominator, multiply numerator and the denominator. In the denominator we get 16 plus 9. In the numerator, we have 1 plus I times 4 minus 3i. Multiply. This will give us 4. This will give us minus 3i. That was this one. And this one give us 4i. And then we do another one, a negative 3i squared. And this is 25. Negative 3 times I squared is just 3 added to 4. This is 7 plus I over 25. 7 over 25 plus 1 over 25I. And that's how we find that division. Well, one interesting thing is that all the formulas we know for the real numbers will work for the complex numbers. For example, if you're looking for roots of a quadratic quotient, you just go ahead and use quadratic formula. So in this case, basically we have the solutions are going to be minus b plus minus b squared, which is negative 2 squared, plus 4ac over 2a. So this is 2 plus minus root. Why did I put plus here? This is negative 4. So this is 4 minus 8, which is negative 4 over 2. Well, if you didn't know the complex number, you would say there's no real roots. But here, we can write this as plus minus root 4 times root negative 1 over 2. This is same thing as 2 plus minus 2 root negative 1 over 2, which is 2 plus, we can cancel actually, we can write 1 plus minus root negative 1. In other words, the roots of the equation are 1 plus root negative 1 is I, and 1 minus I, which is its conjugate. So you use the formulas you already have for real numbers. If you see negative 1 in the square root, take it as I, and that will give you the complex number. So this equation doesn't have real roots, but it has complex root, and there are 2 of them actually. Okay, so this was just an introduction for real complex numbers. You have to know how to multiply, add, divide, find conjugate, absolute value, and so on for complex numbers.